All right, so we talked about various heuristics involved, uh, some of the heuristics, but we're going to talk about the main one that Newell and Simon developed. And so, yeah, this was a program that was developed to search the space, the problem space, more efficiently. And by using means end analysis, they use means ends analysis, which is an example of a heuristic search. So it's a search that, is less time consuming, right? It saves you time, but it doesn't guarantee a solution, right? Always. But in this case, it will. The core idea is simply that you must compare your current state with the goal state and identify differences between the two states. And then what you do is you create a sub goal that reduces one of those differences, right? So you examine the initial state and the goal state, identify salient differences between the two states, and then choose an operator that reduces the difference between the two. And then apply the operator that you've chosen. And if you can't, set up a sub goal of getting to a state where you can apply that operator. So I know that's a lot. So I'm going to sort of unpack it a little bit with a more concrete example. So imagine if my initial state is hunger, I'm hungry, right? And my goal state is not to be hungry. So one operator that I could choose is to reduce this difference is to put a sandwich in my mouth, right? But maybe it wouldn't be possible from the initial state. Maybe I first need to make the sandwich, right? I can't just, there's no, I don't just have sandwiches lying around. I have to make a sandwich. So assuming that I have the ingredients, right, I could just make the sandwich, and making a sandwich would then be my sub goal, right? So then I would assemble the sandwich with each step having its own sub goal. So it's basically an iterative process of identifying the operators that you would like to apply and then developing a sub goal that would allow you to get to that operator, and then even maybe a sub goal that gets you to that operator, and so on. Um, and so I'm going to give you an example of of this ends analysis. I'm going to apply it to what's called the missionaries and cannibals problem. Okay, so the problem is that you have to transport three missionaries and three cannibals across a river. You have one boat that can carry two creatures at a time. The problem is that if the cannibals outnumber the missionaries on one of the river banks, then the missionaries will get eaten, right? So you have three missionaries and three cannibals on one side of the riverbank. You have a boat, but you want to get three missionaries and three cannibals to the other side of the riverbank, right? Excuse me, sorry. Their operator is that you have a boat, right? You have a boat that can move one or two people across. Restrictions or constraints of the problem is that one person must be in the boat in order to move the boat. And you can't have more cannibals than missionaries on the same side of the river. So let's apply the means ends analysis to this problem. I got my so this is just a schematic, right? So I have three missionaries. I have missionaries that are signified by black triangles, and cannibals, which are signified by red circles, right? And so let's imagine that my first sub goal is to reduce the number of cannibals that must later accompany missionaries. So I want to get as many cannibals over to the final side as possible. So what do I do? Well, I can move two cannibals over to the final side. That's totally legit thing to do, right? Because it doesn't leave the missionaries outnumbered. And then my next sub goal would just be to simply bring the boat back, right? So if I bring the boat back, well, I could bring two cannibals back, but then why would I do that? Right? It just reverses the thing that I did before. So I'll just bring one cannibal back over, right? And then maybe my next sub goal is to get only one cannibal on the starting bank, right? So, which I already did, but I want to get one cannibal. I want to get one cannibal back on the starting bank, but have the boat on the starting side of the bank. So then I can move two cannibals over to the final side. And then my next sub goal is to simply return the boat for safety. So then I move one cannibal over to the initial side. And then, so now I've reached my sub goal. I've achieved my sub goal of having one cannibal on the initial side. And then maybe my fifth sub goal is to transport the missionaries back over to the final side. So I move two missionaries over to the final side. And then maybe my sixth sub goal is to bring back a missionary to escort the remaining missionaries. So that's what I do. Now, notice how I have to bring one cannibal back over because why? Because if I bring only one missionary back from the final side, right, then the remaining missionary on the final side will be outnumbered by the two cannibals. So I have to move one missionary with one cannibal. Okay. And so now maybe I move my seventh sub goal is to move another pair of missionaries over to the final side. So I do that. Great. And now I got to return the boat. So I'll return the boat with one cannibal. And then now my ninth goal, sub goal, is just to simply transport the remaining cannibals over to the final side. So I move two cannibals over, okay, and then I have to return the boat for the final passenger. So I do that. I can do that with either moving one cannibal or one missionary over. Doesn't really matter. And now I'm at a position where I can get to my goal state, right? I've achieved all the sub goals, and now I'm finally at my goal state. And so I just simply, uh, you know, bring the remaining missionaries, missionary and cannibal over, or the two cannibals over to the other side, and my goal has been achieved, right? And so one thing I want to point out is that this means ends analysis, or sorry, one thing I wanted to point out is that right here, when we moved one missionary and one cannibal over to the initial side, notice how we're moving away from our goal state. By moving one missionary and one cannibal over, right? Now you have, you're probably, where are you? Yeah, anyways, your missionaries and cannibals, you want them over to the final side. So, you're kind of going backwards or moving away from your final state. And this is a critical choice point. And the point that I want to make is that a simple search would not be able to solve this problem because a simple search requires you to get with each step of the search of the simple search, you must get closer and closer to the goal state. So a simple search doesn't allow you to move away from the goal state. And so it wouldn't allow this move, right? And the sort of metaphor is, suppose you're at the base of a mountain separated from the summit by a deep valley. Hill climbing or the simple search would refuse to go downhill, but a means ends analysis would recognize that going down first is necessary to cross the valley and climb the true peak, right? So that's just a metaphor, which is saying what I just said, right? That a simple search wouldn't allow you to move away from the goal state, whereas a means ends analysis would recognize, in a sense, that you have to move away from the goal state um, in order uh, to get to the goal state eventually, right? So yeah, the means ends analysis says that in order to get to the goal state, you have to sometimes move away from the goal state. And a means ends analysis recognizes that, whereas a simple search doesn't. Okay, in the next video, we'll talk about techniques of chess players.